This video will teach you all the basic neural network terminology you need. We will talk about all these topics in great details in the next minutes with the help of images and examples. Neuron is the most fundamental building block of the neural network. In the example, you see a simple architecture with 6 neurons. Every neuron possesses a value which is used in the calculation. Neurons are organized in layers. Now let's see what are the layers. There are 3 types of layers in neural network: input layer, hidden layer, and output layer. The neurons in the input layer get their value from the data. For example, if we have 2 columns for the input, we will have 2 neurons in our input layer. The values will come from dataset, and then the value for the hidden layer neurons will be calculated. After hidden layers are finished, we will have our value at the output layer. We have only one input layer and only one output layer. The number of neurons in the layers depends on the task, but we can have multiple hidden layers in our neural network. If our dataset is more complex, then we will have more hidden layers to solve complex patterns. If it's a simpler dataset, we will need less hidden layers. Now let's talk about what are weight and bias. As we already know, the yellow circles are neurons and they combine for layers. Every neuron has a value. As you see on all pictures, the neurons are combined with arrows. In this kind of representation, every neuron will have a value and every arrow has a value. The values correspond for weights and biases. In this example, the calculation for the first neuron of the hidden layer will look like this. We will take values from our input layer, which is 0.54 and 0.48. They will be multiplied by the corresponding weights, which are 0.2 and 0.1, and the result will be added with the bias value. And the resultant will be 0.216, which will be the value of the first neuron in the hidden layer. So the weight and bias are the connection points between the layers. The values of weights and biases are initialized randomly, and during training phases the values are optimized. Now let's talk about what's an activation function. After we calculate our value for the next neuron, the value will go through the activation function, and then only the result of activation function will be assigned to the new neuron. In the previous example, we found the value of 0.216, but in reality it's not directly written to the new neuron. The value will go through an activation function. In this example, I am using a sigmoid, and only the result of the activation function will be assigned to the new neuron. Activation function is an important factor to introduce nonlinearity in our system. I have a complete guide for activation functions in my YouTube channel. You can check it from the link in the card. The next terms we need to know are forward and backward propagation. In terms of neural network, when you calculate your values from start to the end of the network, it's called a forward propagation. In forward propagation, you give the input and you get the output. After that, according to the errors you get at the output, the backward propagation process will start. During backward propagation, which has been shown as a blue line here, with the use of optimization algorithms, the weights and biases will be optimized. This process continues until the loss value and accuracy value are at desirable levels. To sum up, we have a forward process and backward process. In forward process, you give your input at the input layer and you get the output. After that, you calculate your errors, and then according to the errors, you will have a backward propagation process in which you optimize the weights and biases. What's an epoch? When all your dataset goes through the forward and backward propagation, this whole process is called an epoch. For example, if you have determined 5 epochs for your training process, then your entire dataset will go through forward and backward propagation 5 times. The next terms are batch and batch size. During training process, the dataset is not fed entirely. It's divided into different parts which are called batches. Then each batch is fed separately. For example, in this picture you see examples from CFR10 dataset. I have divided these examples into 4 batches with the batch size of 10. Every batch contains 10 images. This can change for every example. Usually it is set to 16, 32, 64, and so on. And you can change that value as a hyperparameter during training process. In forward propagation, every image goes through the neural network one by one. It doesn't depend on batches. But for the backward propagation, where you calculate your errors and update the weights and biases, batch size is important. The updating process happens only one for the entire batch. For example, if you have 10 images, you will get 10 errors, and the average of errors will be used for that batch. You will have 10 separate forward propagation process and then only one backward propagation for the entire batch. You can also check my blog on Medium about this topic, where I have talked about similar topics with illustrations and explanations. If you liked the video, please don't forget to subscribe and like for more videos like this.